Welcome to the Maguire Iron Podcast. My name is Brian Cooper. I am the Director of Marketing at Maguire Iron and your host for this podcast. At Maguire Iron, we have been helping to store and protect quality water for over 100 years. On today's show, we will discuss the most common water tank styles, the pros and cons of each, and the differences between them. To understand more about water tank styles, I am joined by Rich Kemmis, one of Maguire Iron's water tower experts. Rich began his career in the water tank industry over 35 years ago and has done it all. Rich, welcome to the Maguire Iron Podcast.
Thank you.
Rich, let's start with why do we need water tanks and water towers?
The main reason that we have water tanks is to have a combination of fire reserve and to keep that uniform pressure into a system. If you're using pumps and you're pumping directly, or even in a house where you would pump on your own well, you'll have a big variance in pressures that'll go up and down because there's no large tank to maintain a more steady pressure. So that's the primary reason, is to maintain that pressure. It gives relief to pumps, so they have a resting period. It gives you backup for fire protection, or it gives you a reserve in the event that you lose power. Many little different things that come into play there.
Which is interesting because most people drive through small towns, big towns, and see them, but don't really know why they're exactly there.
Correct. And secondary purpose is it's a great place to put a sign.
Well, and a lot of people do talk about that, is it's a great place to advertise your community, your school, all those things. That's, like you said, an added benefit. Let's take a step back now that we kind of know why water towers exist. Tell us when you got into the industry and what this looked like when you got in.
I started in the business in 1975, and I started in the lowest position in the company, a little bit above dirt, so not a whole lot, and basically worked my way up through the industry. It was pretty rough and tumble back in that day, pretty hardcore, I guess I would say. There wasn't a lot of oversight, there wasn't a lot of safety, and so it was pretty heavy travel. So it was pretty rough and tumble back in the day when I started. And I think even in the 70s, the early to mid 70s, when I got into it, it was even an improvement over what had been previous years. So
how has the industry changed? You touched on it a little bit in regards to safety, but what are some of the things that you've seen personally change in the industry?
Yeah, the biggest one I'd have to say is safety. When I started, we virtually had no safety. Everything was done by hanging on with your legs and your hands and hoping for the best, or in some people's cases, saying a lot of prayers. So that's probably been the biggest thing that I've physically seen. The other thing that I've seen that's been quite an improvement is the quality of paints. The quality, the type of paints for protection, added protection on tanks over what was back in the day. Back in, even up into the early 70s, we started seeing epoxies come in. Prior to that, we were dealing with waxes and phenolics and asphalt-based paints, things of the sort that were relatively short-lived and could be destroyed or pulled off due to icing conditions up here in the upper Midwest. So, coating improvement has been great. Safety improvement has been great. And there's been a lot more oversight. So I think the overall quality, performance of workers in the industry has improved.
You said you've been in the industry since 1974. What's kept you in the industry this long? What do you enjoy about the water tank industry?
Probably, it's kind of a struggle early on, but probably the biggest thing for me is it's a very exciting job. Something different every day. There's a certain part of danger element to it, which adds to the excitement of the job. the excitement of the business. That's been probably one of the biggest ones. The travel is definitely an issue. For some people, it's a bad issue. For other people, it's an enjoyable issue. There's something about the traveling and new scenery and different parts of the country, things like that. So the traveling has been a big draw, and the company that I work for has been a big draw to keep me here. Very family oriented, very concerned about individuals, and it's just been my pleasure as the years have gone on to spend more time with the company. So it's a combination of those probably three things.
And at the end of the day, you're out there helping bring clean, potable water to communities and people across the country.
Correct.
One of the big reasons we are having you on the podcast is we want to talk about water tank designs. You're a guy who's been on about every one of these more than once. And so let's talk a little bit about what are the different water tank designs that are out there, and the most common ones.
Right. Most common ones, of course, are ground storage reservoirs, or what they call ground storage tanks. And that differentiates from a standpipe, which is also a ground-supported tank, they refer to it as. Ground storage tanks are wider than they are tall. Standpipes are taller than they are wide. So that's their differentiation. Of course, we've seen leg tanks forever, so they're very common. And then we started getting into the single pedestal type designs, which are typically spheres, but there's other ones that are referred to as a hydrocone. There's some that are just referred to as single peds, and they might have a different design of a tank on the top, a cone top, cone bottom. Varying little styles there. And then most recent one has been the composite tanks. So
let's talk about ground storage tanks. You gave us a little bit. What is a ground storage tank? Why is it used? Where would it be used? Give us a little detail about ground storage tanks.
Yep. Ground storage tanks are typically used in we need to keep a large capacity of water. They might be used as almost like a cistern or a stepping stage. Process the water, put it in a ground storage tank, then we'll pump it to elevation to get pressures. They're very common in mountain areas where you have a hill outside of town, or an elevation, so that you don't have to build a legged structure or an elevated tank. You can put a tank up on the hill and gravity feed it down into the town, into the community. So that's kind of where ground storage tanks they're there for large reserves. So it's not uncommon to see 2, 3, 4, 500,000 or 5 million gallon tanks. So not uncommon at all.
So what are the benefits of a ground storage tank over an elevated tank?
The biggest one would be, of course, large capacity. You can build them into millions of gallons of tank. They're located on the ground, so a lot of times towns will go in and do their own inspections. They may go in and do their own cleanings. So they're easier to access. They aren't as tall, as scary, because a lot of people don't like to go up very high. So even though we recommend you use a professional company to clean and inspect your tank, there are a lot of communities that have or still do inspect their own tanks.
So that's a ground storage tank. You mentioned about the standpipe is taller than it is wide, which then transfers it into a standpipe category. Talk about a standpipe and what it is.
Yep. Standpipe typically is that narrow as opposed to taller, and it's typically used in a situation. There's a couple of common situations. A small community that doesn't need a lot of water capacity, but they want the pressure. So they'll build a taller standpipe, say 100 feet tall, so that they can have the pressure to the community, but they don't need 500,000 gallons or 100,000 gallons. They only need, maybe 10,000, 20,000 gallons. So they get the benefit of having pressure without a huge amount of volume. The standpipe ground storage tanks are typically cheaper to build per gallon. And probably one of the other areas that a lot of people don't realize, we see a lot of standpipes down in small communities down in the central Midwest, southern Midwest states. The other thing that where it came into a lot of them was in the early days of rural water systems, where they might be dealing with 10, 20, 50, 100 miles worth of distribution. In order to maintain that uniform pressure throughout the system, because you have certain loss, hydrostatic loss, what they call, or line loss, then you put a standpipe here, you put a standpipe another 5 miles down the road, another 5 miles down the road. So you maintain a more uniform pressure throughout the system, and yet you didn't need all of that high volume. So we saw a lot of the standpipes going in the early rural water systems. So that's kind of the two places where we see them the most.
Are there any drawbacks to a standpipe versus another type of tower that somebody may have?
The biggest problem with the standpipe is theoretically you can only count on about 1/3 of the capacity, which is that top third. That's really a useful capacity for the town. Anything under that is getting to be lower pressure, and basically it serves as a fire reserve. But you can't, if you build a 100,000 gallon standpipe, theoretically you only have about 30,000 gallons. That's a useful amount of water for that tank.
And so for our listeners, what we're talking about is when you look at an elevated tank, all the water is being held in the bowl of the tank above the ground, and the column is what transfers the water into the system. Whereas a standpipe, it's the water fills the whole thing, and so that's why Rich is saying you only can use that top third of the water because it's acting like an elevated tank would in that top third. And once you drain it past that, like Rich said, you lose that water pressure that you've built it for.
Correct.
Is there that kind of an issue with a ground storage tank, or not, because you're using the natural elevation of a hill or whatever to take care of that?
Typically, you're using the natural elevation of the hill or up on the hillside or the mountainside, and you're gravity feeding into town, so that whole capacity of that tank works. Unless you're in a relatively flat land and you've got a large ground storage tank, then it's working more like what you would consider a cistern, and you're actually maybe putting your treated water into that tank, and then you're using booster pumps to get it to an elevated tank.
Now, these kind of tanks can be built from what different things? Welded steel? What do we see in the industry out there in the ground storage and standpipe?
Right. Ground storage, you're going to see basically either steel or concrete. Concrete tends to be their pitch, so to speak, about theirs is virtual no maintenance. They're more expensive to build initially, but there's no maintenance on it because concrete, of course, you don't have to coat it or anything like that. If you end up coating it or putting a sealant around it, then you go back to a maintenance issue. So steel is probably the most common. Again, it depends on capacity. Will sometimes dictate what they go with and where the location of the tank is going to be.
And we do see some bolted or glass line tanks in the ground storage and the standpipe model.
And the standpipe, correct. And they're built on a different standard than welded steel. They were introduced basically as a lower cost option for communities who were limited on monies. So that's kind of where they came into inception, and then they've got different coatings on them depending on the situation. But bolted tanks, and we will see them in both ground storage and the standpipes. You will not see concrete in a standpipe.
And so, just because of the cost of design, probably.
Typical cost of design, and then the thing is, and we'll allude to this a little later on a different tank design, concrete is primary property or benefit is in compression. So if you had built a standpipe, and it's been done years ago, it was done back in the 20s where they would build an elevated tank with concrete. The tank part holding the water now is basically put into tension, and tension does not work in concrete. It basically crumbles it and causes it to collapse. So you don't see concrete in a standpipe situation.
So we've talked about the two options for tanks that sit on the ground where the water is held. Let's talk about elevated tanks. Let's start with the leg tank. What is a leg tank? What makes it classified as a leg tank? And what does one look like for people who don't know?
Leg tanks, I think most people have probably seen them. Basically, you've got legs under them, anywhere from, we've seen little three-legged tanks that would probably be in the 20 to 30,000 capacity, all the way up to we've seen conglomerations with 20 plus legs underneath them, depending on design. So leg tank was the original design, way back in the 1800s when, hey, let's put a wood tank in the air. Most of the time it might be on a wood structure of legs and then graduated to steel legs. Legs can either be lattice construction, typically if they're an old riveted tank. Sometimes they were angle, a combination of angles or channels put together. And then they finally went to round legs, so they're basically welded in the industry. We call them cans. So typically pieces of pipe that are stacked together to make round legs. So that was the original and early inception. Of course, it was a lot easier to build tanks on legs back in the day. So that is carried on even to this modern day. We still have leg tanks.
And when we talk about leg tanks, there are different types of leg tanks within that category. What are some of the different types of leg tanks that are most common?
Correct. The most common, the venerable, ubiquitous cone elevated, which we've all seen many times in many small towns. They're a riveted tank with lattice legs, had a rounded belly, a hemispherical belly, straight shell, and then they had a cone top or cone roof, or what sometimes people refer to as a witch's hat. So it was typically called a cone elevated tank. That was kind of the originator when it came to all steel. Wood tanks prior to that were flat bottom tanks, and we still have some flat bottom steel tanks. And from that standpoint, we graduated. There were water balls, there were water double ellipsoidals, there were toro ellipsoidals, there were what they refer to as a radial cone, which was a welded tank design. So a lot of the ones that were riveted graduated into welded designs other than the cone elevated. That kind of disappeared with riveting.
And so when we talk about these different styles of leg tank, that's what it is. It's a design style, but they all fit into this category because they're up on legs above the ground.
Correct. And sometimes they had a large diameter riser column, which might be 3 feet, 4 feet, 6 feet. I think I've seen them as large as 8 to 10 feet, depending on the size of the tank. Or they could be a small diameter, just a riser pipe. So it was just an extension of the mains that were in the ground for the community.
And you talked a little bit about riveted tanks. Why did riveted tanks graduate into steel tanks and they stopped building that style?
Well, basically back in the day when riveted tanks started, of course, there was no such thing as welding. And welding came in the 30s and got to be bigger in the 40s during the war effort. But, they were still, primary construction was rivets. Even, of course, ships and ocean liners and stuff were riveted. That was their best method to make a waterproof type attachment. So we first started seeing field welding show up. I think the actual first welding in the field was probably in the 40s, but we didn't see it commonly until about the early 50s, early to mid 50s. Then we started seeing the welding come into being. And we actually have in the early 50s, we have some tanks that are a combination of welding and riveted. So that's kind of where the transition was.
So that's an elevated tank. Let's move into the spheroid. When did that come about? What differentiates a sphere from a leg tank in that market?
Okay, the spheres are basically kind of a generic single pedestal design. So they typically have what's referred to as a base cone, a large diameter column, and then they have a sphere or spheroid up on the ball there. And then there's variations from that. Hydrocones were one variation of that. I've seen them with a cone top, a cone bottom, and only a foot of flat between the two cones. So there are varying degrees and styles of that tank, but all generically a single pedestal. Probably the biggest thing for single pedestal is the fact that you have a smaller footprint. So in confined areas, you could actually lay it down on a smaller piece of land. If you had a neighborhood in a small or a half lot, you could actually put that down in there. So, and it made it for a more secure structure, whereas you had to put up with years ago people climbing on the tank that shouldn't be on the tank, or graffiti issues or whatever. When you went to a single pedestal design, it's all smooth on the outside, got one big heavy door on the bottom that you can lock, so it kept people off of the tank, and you had a lot less or no issues with graffiti up on the actual tank itself. So,
and as we talk about these, so the leg tank and the sphere today are mostly welded steel. Do those type of structures come in anything other than welded steel today?
No, they do not. The welded steel, just because of it's the fact that you can bend and shape and work with steel, and anybody who's worked with steel realize that once you bend it and shape it, it actually gains strength. Or if you fold it or have a crease, it actually gains strength. So it's just because of the size and the shape of the tanks that's the only thing you can build on a leg tank or a sphere is with steel.
Are there any drawbacks to a leg tank or a sphere? What are, like we talked about with a standpipe and some of those things, are there any drawbacks in those designs?
Probably the only drawback to the leg tank is the fact that over the long haul it's going to cost you more from a maintenance standpoint, because there's, of course, a whole lot more surfaces to paint, whether it being a number of legs, and you have what's referred to generically as windage rods. They may be sway rods, needle rods, whatever the rod situation might be, and you have to prepare and paint all of that. So in the long haul, you're going to end up with more maintenance costs or repainting costs on a leg tank than you would on a single pedestal tank. So that's probably the biggest difference.
And a lot of times, as we talk about all of these different styles of tanks, there is functionality, but a lot of times the designs are chosen based on how they look.
Correct. Sometimes it's functionality. It's just like the difference between a double ellipsoidal and a toro ellipsoidal. Double ellipsoidals are basically designed to support the vast majority of the weight, if not all of the weight, on just the legs. Whereas a toro ellipsoidal has a larger diameter column and has a cone up underneath the belly. That's designed to carry approximately a third amount of the weight of the total weight of the structure in the water. So that was kind of a design issue, and it allowed the manufacturer to get by with maybe little smaller cans in the legs, or whatever the case might be. It was designed, it might have been cost driven, or whatever the case might be.
So we've talked about the riveted cone, we've talked about the toro, we've talked about the double, the water ball, the sphere, the leg tank, the ground storage tank, the standpipe. Now let's get into a little different style tank that's a newer style tank, and let's start with the fluted column. When people talk about a fluted column, what are we talking about in that style of tank?
The fluted column tank actually was an original design by PDM, Pittsburgh Des Moines Steel Company, and it was for that larger capacity elevated tank where you wanted to put the water in the air, but you needed to go to 2 million, 3 million, 4 million, because leg designs, of course, sphere designs, they're limited to capacity. So the hydropillars allowed the fluted columns. They allowed for larger capacity tanks. I think probably the largest one is maybe 3 to 5 million gallons.
So what did communities do up until that point where they figured out the fluted column and figured out, hey, we can actually take essentially what's a large ground storage tank and put it in the air? Because up until that point, if you didn't have elevation to use a ground storage tank, what would you do? Just build more tanks?
Build more tanks.
Okay.
Exactly. So, if you need 4 million gallons of capacity, and I mean, it really is dictated for fire protection and the use of the community and everything else, you may end up with 10 tanks in order to get that capacity, or you may be down to 5 tanks, whereas here we can just build one big tank. And, of course, it's going to be more cost-effective and everything else.
Yeah, because people don't also realize a lot of times that, the tank is involved, but it's the piping and all of the distribution. Every time you build a new tank has a lot of that infrastructure that has to go with it.
Correct.
So that what separates a fluted column from the other ones? Like, describe it for people so they can kind of get a sense in their mind what that looks like as opposed to a tank with legs on it.
The fluted column has a very large diameter column, basically, and it may be 30 feet in diameter. Typically hollow, nothing in it. Some people like the design because they can actually use the lower level as a garage. They've actually put garage doors in them, so it's like an additional shop for a community. The tank itself is up on the top. So everything inside carries a ladder or stairwell. It's going to have a large diameter riser column where the water is going to come down into the system. It's going to be ventilated. So it's basically just a large cylinder that supports the tank on top of it. So that's typically the design of it.
And the tank itself is welded steel.
Correct.
What is the column made out of? Is it steel as well?
Steel.
Okay.
And there's 2 different design styles. One was a kind of a folded crease type column that was PDM style, and then actually Chicago Bridge and Iron actually used a rounded style, almost like a half pipe with straight pieces between them. So it was just those 2 different styles for doing the actual fluted column tank.
And then a design that spun off of those is what we call a composite tank today.
Correct.
What is a composite tank as compared to the fluted column? Give us a little history on this tank.
Okay. The composite tank was basically a design that came out of Canada by a company out of Canada. And the reason it's called composite is because it's using 2 different materials in their best example or their best performance characteristics. So they're using a concrete pedestal with a welded steel tank on top of it. So the concrete pedestal supporting all the weight is being used in its best capacity, which is compression, and the steel tank that's welded, steel's best property is in tension, so we fill it with water, and so you have the combination. That's why it's referred to as a composite. So they look very similar to a fluted column tank, with the exception that the concrete pedestal, again being about the same size and everything else, is going to be supporting that steel tank on top. One of their pitches is the fact that we're using a concrete pedestal, and so there's no maintenance on it. So it's going to be less maintenance. The steel tank, of course, is going to have to be painted and maintained. But again, your overall maintenance costs, according to their specifications, is going to be less than what a single pedestal or a leg tank would be.
And another reason for this style of tank, just like the fluted column, is to get large quantities of water in the air.
Correct. Yeah, they are not cost effective until you get to the higher capacities. And I think probably the cheapest, or I shouldn't say the cheapest, the smallest composite tank that I'm aware of is probably 500,000 gallons. Very few of them. They really don't come into their being or into their own until you get into the million plus category, and then they become cost effective as opposed to other options.
Much like the fluted column is.
Correct.
And what are the drawbacks to these are there any drawbacks to these styles of tanks when we talk about fluted columns and composites, since they're theoretically the same design, just using different materials?
Correct. the biggest thing, of course, would be the simple fact that the fluted column is all steel, so you're going to have to be continually painting. Periodically you're going to have to paint that tank, and so you're going to have added costs there. The fluted column, or not the fluted column, but the composite is going to have, as I stated earlier, is going to have the pitch of, hey, we're dealing with concrete, so you don't have to do anything. Unfortunately, we've seen examples throughout the country where they have to seal them or they paint them, and then you basically defeat that argument on the tank. So the maintenance would probably be about the same. The only other thing that typically we see in the composite tanks is they have all of the appurtenances, the piping and whatnot is stainless steel. So they, again, say we have less maintenance from that standpoint.
And as we talk about these styles of tanks, they're steel, but then the concrete, when you talked about the concrete being under tension, compression, what are you talking about there?
Well, basically what we're talking about is when you create a foundation for, whether it be a tank foundations are concrete, whether it be a tank or a house or building, you're compressing or you're putting weight on that concrete, which is essentially in compression, and that is its big, huge attribute, is let's just compress that and squeeze it, and this is where all of its strength and ability is. So that's where the compression part of concrete comes from. So the biggest problem with concrete is the fact that you better form it up right the first time, or you may have an issue coming down the road.
You don't get a second chance to do it the first time.
Absolutely. So, and well, probably one of the best examples is we've all seen, I'm sure most people have seen, concrete beamed bridges. They have to be what they call pre-stressed. So typically when they form their concrete beam, they have steel cables running through it that are tension, so that takes up the flex and the tension that is going on in that bridge. Otherwise, when it was developed early on, it was just a concrete beam. After a very short period of time, the bridge would collapse because that's a tension situation.
And with every style of water tank we've talked about today, the biggest issue is safety, because of people don't realize when you put that much water in a water tank, that's a lot of weight, and that's why they're engineered to do what they do.
Correct. And minimum, and a lot of people don't realize it, but all steel tanks are built off of one standard, D100 of AWWA, and they are designed for a minimum 100 mile per hour wind, and they're also rated for seismic loads depending on where you're located in the country. So they actually have maps throughout the country that have seismic ratings, they have depth ratings for pipe, and they also have wind ratings. And if an engineer is going to design a tank for, say, I think, is it Mount Washington in Vermont, where the winds are exceedingly heavy, they may put in a cushion factor and design that tank for 150 mile an hour wind. So it just depends on where they're located. And then all designs have a certain amount of what I guess I would call a fudge factor or deterioration factor designed into them. So they just don't go anywhere.
And when we talk about all of these different styles of tanks, the reason there are these different styles of tanks is because they all serve specific purposes based on how they're built, and it's really up to the community, the rural water district, the city, whoever, and their needs as to what they decide to build at the end of the day.
Correct. A lot of it's based on aesthetics nowadays, as a leg tank as opposed to a single pedestal tank. There are parts of the country that I've heard the comment of, well, we want to build a leg tank. And I'll say, well, why do you want to build a leg tank over a single pedestal tank? Well, the perception is it's a stronger and better design. And I basically tell them, I say, they're all built on the same standard. same wind load, same seismic load, whatever the case might be. They're all built on the same standards. So the perception is that a leg tank is going to be stronger and more stable, when in fact it really isn't. They're all rated basically the same.
And that's why we have educational things like the Maguire Iron Podcast, is to try and help owners, communities, engineers, everybody out there, educate them on something that's sitting in their community they may drive by every day that they don't know anything about.
Correct. And I think it's very important for them to understand how it works. Some people are aware of it. Most people are not aware of how it works. And it's a big moniker for the town. And that's why we're seeing better designs. We're seeing better logos and names on them than what was available years ago. And it's also a reason why I think people are also taking in the aesthetics of the tank that they're building for the community.
Thank you to Rich Kemmis of Maguire Iron for joining us today to teach us about the different water tank styles and the differences between them. Remember, you can always connect with us by going to our website, maguireiron.com. You can ask us a question by sending us an email at info@maguireiron.com, or you can follow or reach out to us on any of our social media platforms. We are on Facebook, Twitter, Instagram, and LinkedIn. Thank you for joining us on the Maguire Iron Podcast.